right, we are back. We're ready to continue. Twitch still is telling me it's offline. Let me reload. All right, so I need to eat. And so I had a couple thoughts. So to do. So I've done some of these things. I haven't done how 90-degree turns. I need to do that. So here are the things that are kind of my priorities. A bunch of cleanup on conveyor belts. I wanted to be done with them, but use voxel rotation instead of 4 block types. So originally I thought that the textures couldn't get rotated, and that's why I had to do it this way. But I think the texture rotation happens in the right place, that I can use the voxel rotation that we just added support for now. Try making conveyor belts half height. Just might look nicer if they are thinner. Now that could mean that they are a half height block, so they're halfway up the block. Or it could mean a half height block at the top. So it's the same as deleting the bottom half of the existing blocks. And it also means that you could actually stack conveyor belts one on top of the other, and there'd be room for the things to go through as long as the things are small, like they currently are. If we start trying to make blocks move on the conveyor belts, then they wouldn't work. And that's kind of an interesting game thing where, like, oh, I want to reuse this conveyor belt system for this more advanced stuff I'm doing. Oh, it doesn't work because I didn't leave room for the full height blocks. I need to split the 90-degree turns because those need to integrate into the belt topological sort as well. And they'll be asymmetric, so it'll be kind of an interesting, different behavior that I'll have to figure out how to make work. We have this whole thing with whether the last slot is going to be filled or not, to prevent two different things from trying to push an item, like two belts coming from different angles, from trying to push an item into that same slot. And once we have inserters, pickers, the pulling things off and putting things on conveyor belts, we maybe need this notion that they've said, I'm going to put something there, but they have to animate it. So they put the promise in so that nobody else is allowed to do it. And that will help our animation and simulation stay in sync, because the promise reserves the animation slot. And then when you get to the simulation and you actually try to move it, you can check that there is a promise there. And if there isn't a promise, then the simulation got out of sync, which can happen if you like update a conveyor belt middle of a tick. Like, that's just always going to be a little broken. So, but I was saying I'd like to move on from conveyor belts. So, pickers. The idea here is that rather than the machines pushing things directly on and off the belts, you have some kind of some kind of thing that goes out over the belt and grabs the thing and pulls it back. And then that can have a little bit of flexibility of position and not always pick from exactly a fixed spot, which will feel nicer. And it'll prevent you from packing machines so tight. It'd be fun if the player could ride on a belt. Yeah, that'll just be a hack that we override the physics sim if you're standing on a belt. I guess we just feed in a force. We update the world sim. Any physics object that's on a belt gets a little force or relative velocity or something added in. Yeah, the vertical belt thing is a thing I talked about, and I think I don't want to do. I think I kind of want to intentionally make you make these, if you, for some reason, need stuff up, you have to make this big bank of tilted belts, maybe going into spirals or something. Because it doesn't hurt your throughput to do that. It just takes longer for the thing to get there the first time, but once you've got a solid row of stuff going, it doesn't slow it down. So making you build more elaborate things is useful. And in fact, it might be interesting if early on you don't actually get the option to destroy terrain, so you kind of have to build around the terrain and deal with that. Maybe you have to get upgraded tech before you can actually start removing blocks and flattening the world to build simpler machines. I think the only way I can do this with animated blocks is the right way to do it. Since the thing does support texture rotation, I don't need to make unique ones for every facing. So I just have to make two, a left turn and a right turn, which won't use up too much. Redo these. Kind of did that. We did that. I haven't done this as an object system, it's just in the logistics sim. Okay, I haven't done any of these. Excuse me. We haven't done that yet. Okay, so so the big question is, should I try to polish up conveyor belts or should I move on to non-conveyor belt stuff? Somebody suggested that items coming out of a furnace could be hot and need to be cooled before they're manipulated. And just having them go far enough on a belt would do that. That's definitely an interesting idea. It's something I kind of thought about. You can build a water cooling system or something as later tech, but early on you would just air cool things. The only downside is we'd have to actually, the representation of our logistics objects would need to not just be the type, but would actually have to have that state of how hot it is. So the memory used by belts would have to double or something. I mean, the same is true if we wanted like qualities. If an item that you've produced could be of multiple qualities, like Stardew Valley has that, then you would need some extra bits, or you would have to just have that be part of the type. So if you needed extra bits for quality, you could go down that route. Yes, I have a 9-to-5 job. Okay, everyone in chat is saying non-conveyor belt stuff. The thing is, without the 90-degree turns, it's really awkward. But yeah, we can come back to that stuff. It should be independent. Let me just make the conveyor belts half height just for fun, because that's a one-line change. That's these. Let's do slab upper, because that makes everything, all the simulation correct. Let's see if that works. Yeah, because I made it upper, it should still line up with the eaters. That's the idea. Now, of course, they're unsupported. So you would, like every so often would make a solid thing under them or something. But now we can stack them up. Except it's not placing them. I don't know what's going on there. Something that's gone wrong. Can I make the other things? I can't make anything. Alright, why can't I make anything? That should be a totally cosmetic change that shouldn't affect anything at all. Oh, because I'm in a release build though, so who knows? Let's go back to the debug build. Yeah, you can still, the point is with this, either position for the half height, they can still travel under. So, okay, I don't know what happened there, but actually let's make it go in the opposite direction, just to. So, that's kind of interesting. But they look like they're floating, so until I do something smarter, I think I'll put it back how it was. All right. The top half meant that the surface of the conveyor belt was in the same position that it was, so that I didn't have to change where the rendering of the objects was, because the objects being rendered on top don't know anything about the actual voxel geometry. But I could switch them to lower and have to, and fix the rendering of all of them and fix how the connectivity with the slopes works and stuff. And then, that might feel better because they're not hovering over the thing. That would probably be where you would go in the long run. Although it might kind of feel cool to have the sort of raised look as well, if you automatically placed a solid one every so often, or you were forced to support them basically. All right, so what was the to-do list? Pickers, right? Okay, so we'll start by making pickers be machines. Oh no, we won't, right? Because I want them to have a different thing, and rather than make this a messy union, I think I will just make a type def struct picker info log chunk chord pause 8 type. It doesn't need a separate config. It does need a timer. It's more of an animation state. So let's call it state. It can never take longer than 256 frames because we'll have the state just increment. Yeah, it could be a gameplay improvement, that's true, that you start with full height conveyor belts, and then when you want to stack them to half height, that's an advanced type. Although if I don't have research trees, it's going to be the only thing that makes something more advanced is that you have to build a lot of other stuff to build it. And I'm not sure how I could justify that fictionally, but maybe I don't have to justify anything fictionally. So that's 4 bytes. So now we only have room for 16 input ID. Let's do this. Can you do picker to picker? No, you can't. Okay, so input is belt. Let's do that. 16 output is belt. 16 output ID. So currently the existing machine code just goes and finds the belt that it wants to interact with. The idea here is that we would store that in the same way that the belts store their target and input IDs. We'd go ahead and store the things. And maybe this is one case where I don't want to use a bit field. I want to just tag that in the top bit. What's the common case for a picker? Do you pick inputs more or outputs more? You always have an output. You always have an input. You might have multiple inputs and multiple outputs. I think that multiple outputs is pretty rare. So multiple inputs is the common path. So we'll just save that for optimization to be done in the future if we want. So then we need picker info pickers. And so the isBelt means it either refers to this array or it refers to that array. Now the thing is, it might be in a different chunk, and we used to have a flag for that. Target is neighbor. Do we want to do that? We didn't bother doing that for input. So we just manually check that when we have to do that? Is that how the input ID thing works? That's part of visit, right? If we have an input ID, we always do a get chunk. Right, we never optimize that get target chunk anyway. Get target chunk always does it. The whole point of that neighbor flag was to let that target chunk get optimized. So everything is order 1. It never has to do a search. Although the get chunk is still order 1 too, actually. So that would then limit us to 14 bits. But that should still be fine, right? We're limited to 32 by 32 by 8 or 4. I think it's 8. This logi chunk variable. Yeah, so it's 8. So 32 by 32 by 8. I've written this up before. 2 to the 5 plus 5 plus 3 is 10, 13. 2 to the 13. So we need at least 13 bits. Worst case. So we do have room for it. Now, of course, you can compute that, whether input is neighbor, output is neighbor, also in order 1 time, just by using which way you're facing and your position and where you are in the grid. So this is all a super optimization. So let's not worry about it for now. All right, so whenever we update a chunk and we find our targets, we also need to find the targets for the pickers. So we have to do for I equals 0, I less than s to be r len c arrow picker. I should fix that inconsistency. Chunk D equals C. Picker info P equals I C pickers I. Eventually, you might have long pickers the way Factorio has long inserters. Well, I guess they do want 1 bit of config, whether they access the far or the near. Let's just make that part of the type. Which side of the belt they access, because you can. Common idea is to store different items on each side of the belt. Yeah, I haven't worried about fixing the facing of how machines are created. In fact, I was thinking that was another thing I thought of while I was when it was off camera. I have a really simple thing I can do, which isn't ideal. Block rot is whenever you rotate a block, let's set the default rotation to whatever you just rotated to. That way, when you rotate something and then place a bunch more of that, it'll come out with the same rotation. Right, like that. Except it won't work for conveyor belts because they use block base. If block base greater than equal BT conveyor east, or block base less than equal, what's the last one? That, well, it'll be east actually, but. And of course, as soon as I switch conveyor belts over to using rotation, I won't have to do this hack. But for now, I have to do this hack like that. I think that will make things better. I actually think the Minecraft stairs thing is a big issue because you see people trying to do prettify things, and you have to like jiggle around to just the right angle or come in from the back because you want to make this weird stair placement. Like, I don't think the stair rule is actually very good. Also, it's really a pain in the ass to build stairs up while standing on them, because if you like look back, it creates them at the wrong angle or something. How does that work? I guess it's okay, because you want inverted stairs under the stairs, and it doesn't do the right thing. Anyway, so I think that'll help. But we'll see. I think what you actually want to do is do something like this but maybe keyed to the machine type. So each time you store this separately for each machine type. And so when you place down a machine, it always places with the same orientation as the last one of those that you placed or rotated. And conveyor belts want to auto connect to adjacent conveyor belts rather than use the last one you did. And definitely don't want to do the camera facing, I think. Okay, so pickers. So when we get a picker, we always want to look one off from it. This is the direction it's facing. Oh, the pickers do need a direction. I didn't store that. Don't have room for that. Oh, that's the wrong one. Don't have room for that. Okay, so now the picker can only take 6 ticks. Or I could fold it into type. I could only have 64 types of pickers is probably plenty, actually. I'm sure this, actually, the state being 8 bits is plenty as well, but we do not need lots of types of pickers. So also, I could first make pickers work and have them computed on the fly rather than doing this update here. And then the update is just a cache of the computation. So rather than building it cached first, I could just try to go straight to do it directly and then build the cache once I get the first case working. That might be smarter because then it's easier to debug in place. But I've been doing it this way for the other things, so I'll keep doing it. So this is p arrow pos.unpacked.x. And then that's relative to the base. Yep. Okay, so we're looking to see if there's a belt right in front of it. Yeah, we never actually made that as a separable thing, did we? Does belt intersect? Get interaction belt. That is actually the thing I want. But I don't get back. I get the position along the belt, but I don't get back whether it's. Yeah, I get back that. Let's just do that. I've got like so many redundant versions of this at this point. Does belt intersect? That's all we need. We'll return J. Also return -1. All right. So I keep overshooting this. I keep forgetting that this is actually up there. Get interaction belts. Get belt ID. target, and then let's change these so they fit in 15 bits. Because I stole 1 bit in that thing. If ID is greater than equal 0, then picker output or input ID equals ID. So ID greater equals 0, ID colon target none. Our input is belt equals true. Then we want to check base x plus, well, let's call this input x and y. Oops. And then output x and y. So we'll have it process opposite sides. And then let's do this. These are not EX and EY anymore. This is input X, input Y. This is output X, output Y. Actually, let's do this different. If ID is greater equal 0, equals ID, the output is belt equals true. Else, then we have to find a machine. ID equals get machine ID hux void basically plus p pause unpack z. And then p output ID equals belt equals false. So like in a simpler world, we would just store all of the things in one big array, and then we would just have an ID. But because the belt runs are very different size data structure, we don't want to do that. So we need to do the same thing. ID greater equals 0, else. IY. Why did that? I wonder how I did that. Okay, so that makes sense. It actually wants to find a belt on a different level, right? Is that the same? How did we do that with the machines? Or either get interaction belts -1, right? So we're not using get interaction belt anymore because we're getting the belt ID instead, so that we can cache it. So if it's coming from a belt, we want to look down 1 to find the belt. Which will be really annoying to recover which chunk it's in, but all right, that's life. So it'd all be so much simpler if these weren't chunked. Chunking is killing this, look, the complexity of this. But it does make everything smaller too, so maybe worth it for big factories. Who knows? It may be, this may all be premature optimization, right? Maybe all these things should just be 256 bytes a piece. And if you have a million machines, 32 bytes, it's only 32 megabytes. Maybe that's not that big a deal. So maybe I shouldn't be bit packing all this stuff. Mainly, I think of it, making it small is good for cache. That's sort of the logic behind it. Not so much the total memory usage, just to make sure it stays in, as much of it stays in cache as possible. Okay, so at this point, we've in theory said all that stuff. So we need to create picker like this. Void create picker. Chunk C. Void Oz int type int raw. I should have just cut and pasted that. This is a picker info. And we push pickers pi. Destroy picker. I'll need to find picker. Let's just cut and paste this whole thing. Find picker. Pickers. Pickers. Destroy picker. Find picker. Delete picker. Probably correct. So then where do we call create machine? Oops. So if type is greater than equal bt picker, and if type is less than equal bt picker, because we only have one for now, create picker ox or oz type rot. And then where do we destroy it? Here. If old type greater than equal bt picker, old type less than equal bt picker, else destroy picker. If you've heard some of that discussion of if something's only called once, maybe you're better off inlining it. This is one of those cases when you could consider inlining that. But I don't think in this case, these are solid enough abstractions that I feel like splitting them out. You don't care about the details of what's going on inside them at all. They are a separate system, basically. So there's no real advantage to inlining that. Okay, so now we're creating and destroying them, and we're caching the info for them. We don't actually have the type defined yet, I don't think. Oh, I have to add the rotation to the picker. Oh, I called it dir. Yeah, let's call it rot to be consistent with machine. Even though it's called dir in the belts. But that's because the belts are actually moving in a direction, which is why it was called that. Dir becomes rot. Get machine ID undefined. Okay, oh, I didn't create that function. Just get belt ID. Machine ID. I guess I just want the same exact logic. machine. Oh, right. I want the, there is search logic for this somewhere already. I remember writing it. Packed. Let's search for packed. Find machine. Okay. So we get the chunk, and then we call find machine, which takes the chunk and the relative coordinates. And it returns the same things. Okay, good. We don't need J anymore. And yes, I've never defined BT picker. Sure, let's just call it 254 for now. At some point, I will invalidate the save games and reorganize all these into something saner. In fact, I did once, and I forgot to reorganize it into something saner. Okay, so in theory, I can place them. It'll cache their state, but they don't have any behavior yet. I need to actually add a hotkey to create them. Why does that startup take so long now? That's main. K equals base equals BT picker. Let's see if it actually takes a long time again, or if that was like a caching thing. No, it's taking a long time. Okay, let's see where the time is going. Took a while to load all the textures, I think. Load edits did not take any time at all. And it starts instantly once I did that. So I think it's just in the render init, but I didn't add a lot of textures. I only added, oh, but they're PNGs. That's why I chose to make them JPEGs. Was because I knew PNGs would take a little while to load. Well, it still took a while to get there. Not sure. Well, I do have on my to-do lists speeding up texture loading. And this is why. I don't remember it taking that long, though. That's very weird. Okay, anyway, so we get in here. We should be able to place pickers. We didn't give them any graphics yet, so they won't show us anything. What did I bind them to? 8? Yeah, so it just gets darker without drawing anything. All right, so we need to give them geometry and textures. So geom for block type, BT picker solid, and then we need a texture for them. So on their front we'll put an eater, and on the back we'll put a maker. Oh, I'm going to replace all these graphics, so I don't, this is all just a hack for now. So block type, texture, BT picker, BT gravel. No, not BT gravel 2. Use the gravel texture just to make it distinctive. 8. Okay. So that's correct. It doesn't have any behavior yet, so we can't expect it to do anything. So 0, 8. Okay. So it's doing something. So now what we want to do is change the OR makers and OR eaters to create their outputs, but leave them sitting in their outputs, and vice versa. So they need an input slot. So logistics, go to the machines rather. The machine has an output. Let's put that at the top. And it'll be contextual for whether that's an output or an input. Eventually they need multiple inputs, which is the input flags, and we'll eventually handle that. But for now, we'll just stick them in the outputs. Okay, so to start with, where's the tick? Went to 0. Okay, here's this stuff. So to start with, they are going to do nothing. And a picker wants to run before or after. If you run before, it lets it start. We kind of want to run, this is that same thing. We kind of want to run the pickers both before and after the machines. Pickers that feed machines want to run before so they can feed the machine, and the machine can instantly start once it gets fed. And the pickers want to go after. Now we could just always run them after, and you lose a little bit of speed, and then we compensate by shortening the time that the thing takes. Since it's all internal to the machine, you never see it. So I guess we can just do that because it'll always be consistent. So run the machines, and then we go, was it I or J? I. M less than SVR len, C pickers, plus M. Okay, so for each picker, what do we want it to do? Let's just have it instantly teleport its input to its output. Okay, so first we have to find the output. So if actually no, let's do a two-step thing. Let's have it move it to an internal buffer. Oh no, I don't have an internal buffer. There's no state for an internal buffer. So I do need more state for this. Yeah. Okay, so let's stop packing these. Where are we at? 2, 4, 5, 6, 7, 8, 9, 10. Let's aim for 12 bytes for now. Unit 8 item. So it's got an item that it's moving statefully over a short period of time. Okay, so picker info pi equals address 0 pickers of M. If pi arrow item is 0, then we can pick up a new one. Else if pi item is non-zero, we want this same logic as well. So if we don't have an item, if we do have an item, then if we went to 0, then we output it. And otherwise, we do nothing because we're internally moving it. Okay, so Okay, so in the real version of the picker, the state is going to like be the position of the grabber, and we'll have to actually animate it between the various positions. But these are only happening on long ticks, so the animation, if it only takes one long tick, doesn't actually have to do anything stateful either. So, but we'll want to store what the item is so that we can draw it while it's pulling it back. But for now, we're just going to make it be a block that the item moves internally and we don't see it at all. So if the item is 0, then we do input. So we first of all check pi input. And we only want to do this if pi arrow input ID does not equal, what are those called? Something underscore none. Target. Probably not what I should, I probably should rename this to not be targets. Should be IDs probably. So if input is belt, then we have to find the belt. So we have to compute the coordinates of this exit point. Where was that we were already doing that? It's in the update. It's here. So you basically have to do this stuff again. I never needed this. But we don't have to do the get IDs because we've cached them. So instead it's logi chunk d equals get logi chunk. Is that what it's called? No. What was that function called? Logistics get chunk. Great naming conventions here, boy. Logistics get chunk for ix, iy. Oops, it must be right here. No, okay. So p arrow pos dot pi now pos dot unpacked dot z minus 1. Okay, so that gives us the correct chunk, and then a belt. Insert input ID less than SVR len the arrow belts belt reference. Do that here. We have to actually process it still, but otherwise, then it's not a belt. Then we get the chunk not -1. Should probably macrofy all of that. And we're looking at do machines PR ID. So we have to assert DR machines. We're going to want to forbid pickers from picking from sloped belts. So where did that happen? Input ID. Search for output. Oh, here. Wait, the create picker. Did the create picker initialize this? It initialized it to 0. Okay, good. Output ID. Now I forgot what I was looking up. I have no memory of why I went looking for that. Okay, what do I have to do? I have to get an item from the belt. So I have to check where along the belt I would be. Yeah, I don't remember why I went looking for that. To do that, I need the coordinates of this belt, which always requires that messy mess. Logistics get chunk. This is the get target chunk thing, I think. No, but that's what we use for the... But I need that offset that this computes. Yeah, but that's specific to the belt run. But I need that offset. I did that somewhere else? Oh, I have get interaction belts. Right. But that searches all the belts. Okay, so static int get interaction pause start point and int belt ID. So we can actually just pass in the belt run. This does have to be in the same chunk. So we can just do that. And then we say turn ups. Okay, and then the position is belt x off, y off, all is plus equals b of c off. Maybe this would be a lot less code if I used vectors. Wanted to avoid diagonal pickup. Yes, want to avoid slopes. Want to avoid having the pickup interact on a slope. Thank you. So where does the picker update happen again? It's here. Block core. Here we go. Find the pickers. Belt ID. No slope. No ramp. They're called ramps. And look, it was already testing that. Okay. Because wherever it was I cut and pasted from was also doing that. All right, so what was I just now in the middle of? Not that. I was in the middle of doing something somewhere. I had left this to do something else. I don't remember. I honestly don't remember. Right, I need to know the position log. That's what I was just writing. Get interaction policy. Yeah. Okay. When I compile it, shouldn't that have been the first? Oh, it doesn't warn about that until the next pass of the compiler. So dumb. Okay. So then we just return abs x minus ox plus abs y minus y. All right. So those are all order one time. Where's the simulation of this? Belt tick. Okay, right here. So interaction pause of BR arrow input ID of xi bc plus pi pause. I should just do this. Let's just do this. Crap. All right. So now we know how far along the belt it is, and now we have to do that same sidedness checking. If we want to have it only operate on the near side. And then if you were head on, yeah, let's just do this. No, we actually need to handle the head on case especially though, because it's, all right, so it's not side, side. So side equals D arrow rot minus arrow rot and 3 equals 1. So it's either 1 or 3, I don't remember again. And then the distance along is if it's facing or head on. All right, so if it's sideways, this will return 1. And we want the picker to pick from, you can actually pick from multiple locations. But for now, we'll just have it always pick from just do this explicitly. D rot equals pi rot. If we're facing and they're going in the same direction, we can't do anything. So we'll just, it's the tail end of the thing, but it really shouldn't work. Then the distance along is all the way at the front, which is items per belt side minus 1. Otherwise, from the middle. Okay. So then the slot is pause times items per belt plus distance times belt sides. Did we actually make a variable called that? Yep. Okay. And then plus which side? That's the slot number. So slot is less than D arrow. Not D arrow. D arrow. Oh, BR pi input. Right. So let's make that belt run. So B equals D arrow BR PI input ID. So these shouldn't be D arrow rot, they're B arrow rot. Less than std len b items. Okay, then we can take from that slot. PI item equals PI item is B items slot, and then remove from belt. Remove some. There's one more word in this. I can't remember what it's called. Remove item from belt. Yep. Okay. B slot. There we go. Okay. So if the input is a belt, we take an item on the tick. That's the other thing, is we could make these things happen off tick, which would be kind of interesting. And then if it went to 0, we're allowed to output it. So we repeat this. So we output on the opposite side. If PI output is belt, we have to do all this stuff again. Exactly the same, which I guess suggests that we should modularize that. What is the output of this? Find slot. So it's int find interaction slot find picker find belt slot for picker, and it takes what? It takes a belt ID and a location. We'll see if that compiles or not. If I forgot something. Oh, it has to pass in. Nope, maybe it's fine. Oh, that's wrong. But the compiler would have caught it, so I didn't have to actually fix it yet. And then this one now is the same thing. If it went to 0, let's assert that it only goes to 0 when it's got something in it. And then we add it to that belt. And it better be empty. Okay, so if it's not empty, this is why we need promises. Oh, we can't access B because we didn't return the belt. Yeah, we need to return the belt and the slot. Then if it's 0, we're allowed to do it. Oh no, right, that's how that is. Right, we do it like this. And if there was no room, then we wait, which means we need to re-trigger the timer. When we grabbed something, wait, this is the input. Right, we removed item from belt and we start the timer. And these need to use output X instead of input X. Output ID. Okay. To belt. Item to belt. Yep. Okay. Logistics get chunk take something else. All right. Yep. What's this belt ID? Oh, we have to know what the picker orientation is. Oh, right, because I'm picker info, I called it state. Yeah, for now, let's just use the timer logic, but let's call it state. And I'll tweak that in the future. When we start actually animating it, I'll have to fix it. Base X is not defined. Right. Address of slots. Formal and actual parameter 5. Address of slot. Find belt slot. Oh, I never fixed that. It's in the rotation. PI route. Okay, now, what have I actually implemented at this point? Have I implemented everything? Have I forgotten a step somewhere? In theory, that could transfer between two belts now. C is null. So this is nested in the wrong scope. All right, which is going to be an issue. I've been thinking about this, that this is super nested. So let's tick, long tick, chunk machines, which will also include pickers. So C base X base Y base Z. Void logistics long tick. Long tick is one word elsewhere. Chunk machines. Logic chunk C interface X interface Y interface Z. That's one too far. Oh, no, I didn't call it a long tick as one word. That's wrong. Oh, no, it was one more. All right. Let's just disable machines entirely. I don't know, I may have lost something. Oh, yeah. Okay. So maybe those work. Assuming it doesn't crash again. Okay, so machines are now non-functional, which is expected. Do I still have hack so that I can populate the... Yeah, okay, I do. So then... do that, and now this is doing the thing about the keeping the old rotation, so that's good. Let's me do this. And now we want to try transferring. Oh yeah, I can't jump. Duh. No, wrong. Why is that? Why can I not be able to type 0 anymore? Can I only build? No. Oh, I'm getting in that weird state where I can't build things now. Something loses sync or something somewhere. Try again. I must be hitting a key that breaks something. Let's just make a separate thing. No, that's not working anymore. What's the deal with that? Block base is 2. Did I screw up the rotation stuff? Mouse down, left. Oh, right, I have to run again. Create a block. Below, there, okay. Why is that part of that range? Block base is 2 now. VT conveyor east is 4. What? Oh. All right. And then these, oops, should have saved it first. Yeah, input ID is garbage. I thought we, dang it. This is outputting. We don't actually want to do it on went to 0. We want to do it on item not 0 and state is 0. So we get to keep trying over and over. And PI target ID does not equal target none. Output ID. Some checks you only did type grade the machine and made picker grade the machine. Oh, good point. Greater than equal. Okay, well that happens to work, but you're correct that that is. And that one I did it first. But this one, and this one works. So they happen to work, but you're right. I need to clean that up. Okay, so let's check. So let me remember to save it this time. Save. Place a picker. Okay. -1. Like this 56. Yep, 7 times 8, 56. Okay. So then pause. Pause was garbage. So that's already broken. Get interaction pause. So I'll have to breakpoint there and step into it. But let's look at the code just in case we see it offhand. Get interaction pause. Yeah, normally we check with chunk widget to know where the start position is. Yeah, the input coordinate is not. I was thinking the input coordinate has to be in our chunk, though, because this is after we've displaced it. So it has to be on the belt somewhere. Okay, I think. Let's do that before I rotate it. Okay, now let's try to rotate it. I think this is what it needs to be. We have to move the starting coordinate into the chunk, or clamp it to the chunk, or mod it. Find the offset within the chunk. And then this is just this. Okay, I think that's what it is. X minus B, X off. Y minus B, Y off. I think that's correct. That before I rotate it. Okay, now let's try to rotate it. Boom. And now pause is 0, which isn't right. Is it? Oh, it is right, depending on which side it is. Okay, and then let's start generating things. See if they get eaten. Okay, yep. It got eaten and output. So I want that to face the other way. And then place picker here. That way. Okay, it's outputting, it's inputting on the correct side, but outputting on the wrong side, it looks like. And it's never, yeah. The eater takes on the correct side, but the output goes to the wrong side. I'm not sure why that would be, because we're probably passing in the wrong side, the wrong orientation. Output ID. Yeah, because this uses rot 2. That's 2. Why can we use OZ and not use it? Just for kind of completeness. I can delete it. Eater. And generate some. stop the generator, and I'll see if we've got some stuff looping around or not. Yeah, so you can see it's not consuming at full rate. And even if I set the time up to full rate, it probably couldn't consume at full rate, but that's okay. So yeah, it's outputting every other, and then it's blocked on that side. So we need to unblock it some. See if this reaches a steady state now that there are few enough there. Yeah, looks like that's reached a steady state. It's just going to keep doing that at that spot. So that looks pretty good. I don't actually plan on supporting belt-to-belt transport like this. Well, I could, I guess. It's just lets me see what's going on consistently in a way that I can't when I make it machines. All right, so now we want to change it so that these aren't blocks. These are little animated things. So we have to start writing that. All right, so let's go ahead and commit what we got here. I might have done multiple things here at this point. No, basically it was just the pickers. There was something else that some other thing I did. Oh yeah, I tested the upper slabs. Oh, did I not do a start? I'm sorry, I didn't do a start. Somebody did. All right. I don't know what episode they called it. I don't know if there's a thing to do it, but it's supposed to be 26.2. Whoops. Okay, and then that's this. Okay. So yeah, let's go ahead and make them animated rather than worrying about getting the machine stuff going. So we need some kind of polygonal model renderer, and we'll just make everything out of cube shapes to start with, so that we don't have to like build. We're not going to bother doing instancing and stuff like that. We'll just immediate mode this all up. So. But we're still going to let we're going to let the logistics system render these rather than make them physics objects. So when we get here, we're building the sprite array by calling add sprite. So we can also do immediate rendering. So GL, do we have GL in here? Yeah, we do. Because I thought I might do it this way originally, and then I ended up doing the add sprite thing. So matrix mode, GL model view, GL push matrix, GL. Do you do translate and then rotate, or rotate then translate? It's been so long since I did this stuff directly. You translate. X, base Y, base Z, info, equals address C of pickers of A. SPI, pause, unpacked X, Y, Z. So rotate F. What does this take? The distance in radians? X, Y, Z, around the Z axis. Actually, that Dropbox thing, I can just use that. All right. So pop matrix at the end. Let's just draw. Everything faces east to start with, so that's along the x-axis. And our origin is 0, 0, so we actually need to translate to halfway through the block so that the rotation works well. But we don't bother doing that for the Z. So everything is 0 to 1 and negative 0.5 to 0.5. So we draw a box. This is the center point. Let's draw it halfway up. And then it's 1 wide. And it's very skinny, and it's very skinny. Let's just try that and see what that does. And then we need to not draw it. So we need to not add it to the mesh. So when we call mesh builder, change block, okay, then we have to be a little bit smarter here. So if EL blocks SC Y of SX dot type. How do we do this? If EL blocks of SC Y of SX dot type. If type. Let's just brute force the enumerate this. If type is BT picker, then we do something else. We do the normal thing. But we still want to update the physics cache and the logistics update block. Okay, if it's a picker, we don't need to do anything unless SX.type is not empty. Or SX.type. Yeah, it's just not empty. If it's empty, we don't have to do anything. It's never going to be BT picker because we're not actually going to put pickers into the block types, which means we shouldn't actually be using the block type for this. We need to introduce a new enum and the mapping, which will also help us with the conveyor whenever we want to place an object that takes up more than one voxel, or we want to do the automatic adaptation of things to meet up. But since everything's blocks, you can't do that much automatic adaptation anyway. So if it's empty, we don't have to do anything. If it's not empty, we want to force it to empty and do an update. We don't care about the rotation if it's empty. If the type is not picker, and what's already there is a picker, that won't even show up here. So we'll create a block. The logistics update will destroy the picker. So I think that all works. I think we want this all to work a little bit differently. The edit list, the edit chunks currently keep track of block types, and we want the edit lists to keep track of these abstract types. But the gen thing also currently looks directly at them and uses them as blocks. So that was why I was saying I think I need to add another layer separate from the edit chunks that is just the edit chunks are block edit chunks, and we want a user edit chunks. So I think this is right. But who knows? We'll see. Okay, they're rotated the wrong way. I don't know how that came out wrong. Oh, well, let me try rotating them and see whether I screwed up the rotation itself. It would be nice if I knew which end was the input and which one's the output, but oh, why is it not letting me select it? I thought it was still a physics block. I thought I made it a physics block. It's not letting me select it. Why is that rotated at a funny angle? Is it in degrees, not radians? Is it GL in degrees? That's probably the case. Okay, so then why did this update physics cache? Why would the picker not? It doesn't call force update, but the physics cache doesn't rely on force update, I don't think. Yeah, that only affects the rendering mesh cache. What am I low on space? Oh. Yeah, my this stream, the capture is about to run out of space, so let me stop and restart it. But we're gonna still consider this all one continuous stream.